Hey guys, Mr. T here, just doing a quick lesson video for the last three topics leading into your statistics test for Year 10 Mainstream Maths. You'll see that this is very quick because the last three topics barely have any maths in it. You're just reading off graphs. So the first idea we need to go over is the idea of bivariate statistics. All the graphs we've discussed so far represent the frequency, or how many times something happens, the distribution of that of one particular variable. The remainder of this topic investigates the relationship between two variables. Instead of telling you how many times one variable happens, we're looking at the relationship between two. This is called bivariate statistics, bi meaning two, variate meaning variable, and statistics is the topic that we're dealing with. So the first set of notes that you should probably get is, in relationships between two variables, there is always an independent variable, otherwise known as the explanatory variable. Why is it called that? Because it explains changes in the other variable. This is always on the x-axis. So the independent variable, the one that causes changes in the other variable, must be on the x-axis, which is the left and right, the horizontal one. The dependent variable is the other variable, is also known as the response variable. This is the one that changes due to changes in the independent variable. That must always be on the y-axis, which is the up and down axis on your graph. So that'll be the first time to pause the video for notes. Can you get those down, please? Okay, line graphs. Now that we've discussed what dependent and independent variables are, we can go into line graphs. They're used to show variations between two quantities. Most often, line graphs are used to show the variation in one variable, the y-axis, so what happens with the response variable over time, which is the x-axis. Line graphs are only appropriate when the independent variable is time, so you should only be doing these line graphs, connecting the dots, when the independent variable is time, because the passage of time, you don't get a chance to change that. The passage of time is constant, so the lines between data points on a line graph actually mean something. On a line graph, if the line points up to the right, then it has a positive gradient, which means that the dependent variable is increasing over time. If the line points down to the right, then it has a negative gradient, which means that the dependent variable is decreasing over time. So another pause for notes for the video. I'll move on. So here is an example of a line graph question. The temperature in a yard was recorded every 2 hours from 6 a.m. to 6 p.m. The line graph below displays the results. What was the temperature at 8 a.m. So I look along the x-axis, which is time. 8 a.m. is here, goes up. The temperature was 26 degrees. What time was the temperature the highest? So I'm looking at the temperature axis. Whereabouts was it the highest up on that line? It was in line with this. It was at 2 p.m. When was the temperature increasing? So it's increasing if it's going up to the right. So increasing here, increasing, no longer increasing. So it was increasing from 6 a.m. to 2 p.m. Estimate the temperature at 5 p.m. Why is it asking you to estimate? Because it was doing the time every 2 hours, even numbers. So I'm not actually going to get 5 p.m. on the scale. However, 5 p.m. is going to be between 4 and 6. Draw a line up there. Between 26 and 28, it's going to be 27 degrees Celsius. Okay, that is line graphs for you. Moving on to the next lesson. I'll pause for notes here. Well, you will pause for notes. Moving on. Scatter plots. Just another quick lesson here. Scatter plots again show the relationship between two variables, but the independent variable does not necessarily need to be time. Really, the only difference between a scatter plot and a line graph is there's no lines between the dots because the x-axis is not going to be time, so the lines won't be meaningful. So example, the scatter plot below shows the ages. The independent variable, we're saying that age causes change in the amount of work done by people. We have the scatter plot showing ages and work done by 5 employees. Which person is the oldest? So we care about age. The furthest along there is E. Who did the most work? Now we care about the y-axis. What's the highest on the y-axis? Who did the most work? Both B and E did the most work. Who did the least work? No, too far down. The lowest is A. Okay, that is how you deal with scatter plots. So pause for notes. But I'll move on in the video. Lastly, correlation. Again, no real maths here. You just need to be aware of correlations to read correlations off of a graph. The more significant use for scatter plots, so where scatter plots, the last little topic, was useful, is when we look at the correlation between two number values. Ignore this. This is just me telling you that I teach year 11 and year 12 general maths, so I know where this is all leading to. But I'm only going to teach here what you need, okay? And sometimes it's just useful to be aware of this. So the correlation between two numerical variables is described with 5 different characteristics. The first one is the direction. This is how the dependent variable acts, so the y-axis variable, how it acts while the independent variable increases. So as the independent variable goes to the right, what is the dependent variable doing? That direction, that shape that these dots form is the direction of the correlation. It also happens to be the general direction the points form on the scatter plot. So if you have dots forming in a shape that goes up to the right, we call that the positive direction. What's happening here as the x variable increases, the y variable also increases. If the dots are going down to the right, well, the x is increasing, but y is decreasing, so we call that the negative direction. And if the dots are randomly scattered like this, we say there is no correlation. Pause for notes. Linearity. If a correlation exists between two variables, the point's closeness to forming a straight line is called its linearity. So if we have dots on a scatter plot and it looks like they form a line, not exactly, but close to it, we say it is a linear correlation. But if the dots are kind of close together, not perfect, but if they're close together and form a curve or something that is not a straight line, we say it's non-linear. It's a non-linear correlation. So pause for notes. That's the second aspect. The third aspect is strength. If the data does form a pattern or a trend, then the closeness of the points to that trend is the strength of the correlation. So if the dots are forming a shape and they're very close to that shape, like you see here, we say that is a strong correlation. If the dots are forming a shape but they're sort of a little bit far away from that shape that they're forming, we say it's a moderate correlation. And if the dots are somewhat far from the shape that it's forming, but there's still a clear pattern, we say it's a weak correlation. Pause for notes. The last one I'll be going over today, because you don't need to worry about causality at this year level. So we're only going over 4 out of the 5 aspects that form a correlation, is the idea of outliers, which we've spoken about before. If the data points lie, oh, I didn't want to draw there. I wanted to arrow, laser pointer. If data points lie away from the main pattern or trend of the other data points, we say there's outliers in the data. So you can see here, the most of the points on this graph are forming a linear positive correlation that's like moderate. But then we have some dots that are far away. This here is not an outlier because it lays on the main trend formed by the majority of the points. These points are forming a linear correlation, and this point, regardless of it's far away, it still sits on that trend. These points, however, do not sit on the trend, so we call them outliers. So that is the last notes that you should probably take. Pause for notes. That covers the remainder of this topic. You'll be revising for your test next week for the rest of this week. Okay, hopefully that helps you out. And I will see you on the next video.